Hi guys, I'm sorry that I am still sick, but I have an exciting lesson for you on logic today, which is what we're going to be talking about in geometry for the next several blocks. Logic is a system in math that we use. It has rules and reasoning that allows us to judge and create valid conclusions based on some geometric principles. Basically, by applying statements in a precise way, we can decide whether or not they are definitely true or false from the given facts. There is a lot of notation and symbols that we're going to be introducing today, so please make sure that you're taking notes as we go. So let's kick this off. Translating. So first thing you know about translating is that in order to make an argument, first you need to start with a hypothesis, right? And our hypothesis in math is always going to start with an if. It's the if part of the statement. It's saying that if something happens, then something else will occur, okay? And the entire part of this hypothesis, that entire section, we call it the P, the first part. Why P? Not entirely sure. If you've ever heard people say mind your P's and Q's, always remember that P is first and Q is second, okay? So if I'm looking at the example right here, it's given a statement. It says, if today is Monday, then I'm very tired, okay? So the part that's after the if, I have an if, right? Anything that follows is going to be my P. So if today is Monday, right? P then refers to this entire idea that today is Monday. Now it may or may not be Monday. We're just saying that if today is Monday, okay? The conclusion follows after that, okay? It is the then part of the statement. Okay, conclusion follows P's and Q's. It is after the then. Okay, and it is always given the letter Q. Okay. So, using our example here, if today is Monday, then I am very tired. Okay, here's my then. I am very tired is going to be my conclusion. So what they've done is they've set up a situation where there's a condition and a result, right? Condition and a result, okay? So there's a couple other ones that you need to be aware of as we're going through here for symbols. But why don't we take a look at this. This, if you are in geometry, then you took Algebra 1. Okay. And it says, dogs are pink if I'm a cat. Oh, that's sneaky. Okay. So I'm betting that you can figure this one out. Give it a try on your own. Right. And I'm betting that you were able to identify that this if part, what comes after, you're in geometry. You are in geo, and then after that you have then you took Algebra 1. Okay, this one, however, is a little more complicated because it doesn't have the same order. In English, we like to move things around, right? So let's take this one at a time. Dogs are pink if I'm a cat. See how they threw that if in the middle? It doesn't matter that it's at the end this time. If doesn't have to be at the beginning. It usually is, though. Whatever that condition at the beginning is, all right, we're looking for a condition and a result. This is the condition. If I'm a cat, the results are then dogs are pink. So if I am a cat, has to be our hypothesis, and then dogs are pink is our result, right? Our conclusion. Okay? Alright. So, there's some other symbols here that we're going to talk about and take a look at, alright? So, when we're making if-then statements, this symbol denotes that we're making an if-then statement, okay? If you have an arrow, it's pointing like this, and what you'll usually see is P and then an arrow and a Q, right? If you see that, it means that you've got some hypothesis, if this, then this, right? So the arrow means if then, okay? This one up here, this negation symbol is important. It means it's the opposite. It will mean it is not, okay? If and only if is a double-headed arrow, and it requires a little more conversation. If and only if, okay? And that's often referred to as IFF, if and only if, okay? And then here are the ones that also you need to be aware of because they affect how our conditions play out. Therefore is the conclusion that you draw based on the statement. And is if you would like to combine statements. And or is if you have one true or the other. And both have to be true. Or you have one true at least. Okay, they can both be true, but at least one has to be true. You'll notice the and symbol kind of looks like an A, right? Alright. So let's take a look at some examples, and then I'm going to have you do some practice on your own, okay? So here are some examples. They have given us 3 statements, and you are going to put them using this words, using these symbols, lay them out, okay? So we have the statement S, A is on line AB. J, A is the vertex of ABC. And statement T is A is not a plane. Not a plane. Okay. So if we have S and T, alright? So that means that we first have to start with this statement, okay? Our statement S. Let's switch pens here. That one's running out. S and T. So we start out with S. S is A is on AB. Okay. And then you remember what we said that this pointed up looks like? If we have a symbol like that, it means that it's going to be an and. Right? This symbol is and. An and symbol because it's up like an A. Alright? So then we say and, okay, T. So then I go and I find my T statement, which is over here towards the end. Okay, and T, A is not a plane. Okay, so this would be the full statement written out using these statements, okay? A is on AB and A is not a plane. Okay, let's try again. We've got S, that would be an or, J. Okay, so S again, we're starting out with A is on AB. Got you. But this time, instead of an upward facing caret, we have a downward facing one. That's our or. So, or, and then J. A is the vertex of ABC. So I just write that whole thing out. And get a different color. A is the vertex of angle BAC. Okay. So here we started out with S, and then we have the or, okay, and then we ended with our statement J, just right here. See how we're using the same statement for S each time? And what's making a difference is which statements we put together and also which ones we use. Now this time, we've got an if-then statement starting. That means that before I even write down the S, I need to start with if, right? I start with if, and then it will be S, and then I'll have the word then, and it'll be our statement T. So this one is the same as the first one, but instead of an and, it's an if-then, right? A, B, and I wrote it wrong. If A is on A, B, then okay, A is not a plane. Just filling these in. Okay, so that's how you use and, or, and an if-then. And connects them, or connects them, and if-then connects them, but with two words. If first statement, then second statement. Okay? Now this one has an if-then statement, but it also has a negation. Okay? This little negation symbol is important. It means that you're going to say the opposite of what that statement was originally. Okay, so if our original statement for T is A is not a plane, then if I change it, if I put a negative sign in front of it, it's like saying the opposite of, right? A is not a plane, the opposite of that is that A is a plane. Now it's an if-then statement, so I'm going to start with if, and now I need to negate T. So I do the opposite of T. T is A is not a plane, so the opposite of that is A is. It is, in fact, a plane. Okay? Then, and then we have J, and J is A is the vertex of VAC, so I need to change it so that it is the opposite. Okay? And we say that A is not, so we're doing the opposite with this negation, the vertex of angle BAC. Okay? So that is how a negation works. It becomes the opposite. Okay? I'm going to break here and see if I can upload this, and then you should begin the second part of the video.